Okay, my name is Ryan Wade. I'll be presenting today on alternatives in Power BI. Before we get into the presentation, I'd like to tell you a little bit about myself. I've been a data analytic professional for close to 20 years now. My tool of choice are the ones listed to the right, Power BI being one of them, SQL Server, Modern Excel, and then you can look through the list to see the other tools I like to use. Outside of my data analytic work, I'm a strength athlete, I like to lift weights in my spare time and also spend time with family and friends. Okay, so the goal of this talk is to talk about R alternatives in Power BI. We're going to talk about how you can leverage R within Power BI. But before that, Microsoft have been leveraging R in other tools other than Power BI. In 2015, Microsoft introduced R in Azure ML, and then they made a very big purchase in 2015 with the acquisition of Revolution Analytics. Since then, you began to see a lot of R being baked into some of the Microsoft products, Power BI being one of them, and a big addition was the addition of R to SQL Server in SQL Server 2016.
Oh, so, Brian, just one quick second. Can you just click the little orange arrow on the GoToWebinar just to kind of push that off to the side?
Okay, I'm sorry. Okay.
Perfect. Thank you so much. Sorry.
Okay. All right. So the focus of today's session, again, would be R and Power BI. We're going to look at, went a little too fast, we're going to look at using R and Power BI as a data source, using R and Power BI as additional step within Power Query or Get Data, as it's now called in Power BI, and also we're going to use R and Power BI to create custom visualizations. The tools that we're going to use are going to be part of a group of packages known as tidyverse. For those of you that are new to R, I highly recommend that you leverage the packages that are available in tidyverse. Tidyverse are a group of packages that are mainly authored by a guy named Hadley Wickham. Hadley Wickham is arguably the most prolific developer of R packages, and he has made a bunch of packages that makes doing things in R much easier. Two packages that we're going to use extensively in today's talk are dplyr, and dplyr is based on what Hadley Wickham calls the grammar of data transformation. So he has some verbs, he developed some verbs within the dplyr package that makes it easy to make data transformations to your data set. And in addition to dplyr, another popular package that we're going to use a lot today is the gplot package. The gplot package is based off of a concept known as the grammar of graphics, and what it allows you to do is it allows you to build visualizations by building on elements. A better way of saying that, I know Roger Ping, a famous data scientist, said that with the grammar of graphics, you are able to build visualizations that no one else has been able to build before, in the same sense, in the same manner that you're able to construct sentences using the grammar of language that no one else have been able to construct before. So you're gonna see a demonstration later on in the presentation of us using ggplot2 to develop a nice custom visualization. Okay, so there are some necessary tools that we need to have in order to make this happen. We need a distribution of R on our machine, and the version of R that I choose to use is Microsoft R Open. It's pretty much the same as the version of R that you can get from Crane, with the addition of several features, and we're going to discuss that later. Another thing that you would need would be RIDE. There are two popular RIDEs out currently, one of them being RStudio. RStudio has been around the longest and is by far the most popular RIDE. but recently Microsoft developed RTVS, which stands for R Tools for Visual Studio. What R Tools for Visual Studio allows you to do is not only develop R scripts in the same manner that you do in RStudio, but it also works nicely with SQL Server R services and some of the other platforms within Microsoft. And then we're also going to need Power BI Desktop. Okay, so what are some of the benefits of Microsoft R Open? Why should I use Microsoft R Open and not the version that's on Crane? As I mentioned earlier, there are some enhancements on it, and two of the well-known enhancements is the multi-threaded math libraries. That allows you to do a lot of computations that are based off of linear algebra in a very efficient way. Another big addition to the MRO version of R is the checkpoint package. In data science, reproducible research or reproducible work is very important. And with all the packages that are out there in Crane, you may have a lot of situations where you you do some research, and then an update to that package is later made by the author. And when you try to recreate what you did before, that minor change that they made may affect the outcome of the analysis that you did. Well, with the checkpoint package, it allows you to make sure that you get the most recent version of that package as of the checkpoint date. So what that allows you to do is make sure that if you were to do analysis and you want to pass over to someone else, you can give them your checkpoint date, and that checkpoint will ensure that when they try to reproduce what you did, they will use the exact same packages that you did. Now, this slide needs to be updated. At the time of the original presentation I did this, the default checkpoint was March 15 of 2017. I believe that's the same date. I don't know, but that needs to get verified. In addition to MRO, you also need our tools for Visual Studio, and you can get that by downloading from the link that you see on the screen. And it's part of Visual Studio 2015. It's an addition to Visual Studio 2015 and also Visual Studio 2017. I will be using 2017 in today's presentation along with RStudio, so that you will see both IDEs, RStudio and RTVS. But just note that RTVS is the add-on to Visual Studio. So if you're like I am and you're already used to using Visual Studio for SQL Server data tools and some other add-ins that SQL Server, the Visual Studio has, then the environment will be very familiar to you, and that makes the learning curve that much more shallow. So before you get started with doing Power BI, using R and Power BI, there are some setup work that you need to do. The first thing you need to do is set up RTVS if that's what you choose to use. After you install RTVS and you do your first launch of it, you'll see a screen that looks similar to what you see on the screen right now. And the layout that you see is the default layout that you see with RStudio, and that is where in the upper left-hand corner you will see the script editor. That is a area where you write your R scripts. On the lower left, you'll see an area that is known as a repo. Read, evaluate, print, loop. That's where you do all your interactive programming at. And then on the upper right, you'll see your global, you'll see the pane for your variable explorer, and then also the workspace. I want to note that when you open up your R tools of Visual Studio, you need to make sure that you're using the version of R that you want to use. And you do that by checking your workspaces and making sure that the version of R that you want to use is the one being selected. You'll see that on my machine, I have two distributions of R loaded on my machine. I have Microsoft R Client and also have Microsoft R Open. Microsoft R Client is used with SQL Server R services, and that's not relevant to what we're doing today. We want to use Microsoft R Open, and you see that that's checked, so we're in a good position. The layout that I showed you before is the layout that really is not good for data analysis, because you got areas of your screen being used by panes that you're not going to use that often. The two most important panes that you're going to use when you're doing data analysis or writing R script are the pane that's used for the R editing, the script editor, and also your repo. So this layout right here, I think you will find easier to use, and you'll see that real estate is being used for things that are most important to you. And I mentioned about making sure that your workspace is pointing to the right version of R, so that's a duplicate slide. So that's the setup that you need to do on your IDE, and what I showed you is if you were using R tools with Visual Studio. The second configuration that you need to do is in Power BI. Once you launch Power BI, you need to go to File, Options, and Settings, Options, and R scripting. Once you go there, you'll see the detected R home directories and the detected R IDE. In the detected R home directories, you need to point Power BI to the distribution of R that you wanted to use. And then the same with the R IDE. You'll see that right here I have Visual Studio 2015 selected here, but you can also choose R Studio. On the machine I'm using right now, I have Visual Studio 2017. So you need to note that Power BI doesn't have that on the list as of yet. So if you're on a machine that has have Visual Studio 2017 and doesn't have Visual Studio 2015, you would need to use another IDE. And in this case, on this machine that I'm using today, I use the
Ryan, you there? I think we lost your audio. Ryan? Ryan? You there? Oh.
Yeah, can you hear me now?
Yep, there we go. Perfect, thanks. Got you.
Okay, sorry about that. Okay, so the first thing we're going to do is use R as a data source. And we're going to do three different examples. I'm going to use an example of using R to create a date table. Then I'm going to use an example of using R to do an advanced calculation that would be difficult to do in Power Query. And the last example would be using R to bring in stored data from SQL Server R services. So the packages that we're going to use to create a date table are the LubriDate package and the dplyr package. And what we're going to do is we're going to build this data set in RTVS, and after it's built, we're going to copy and paste the code into Power BI. So to build a date table in R, well, first thing we need to do is load the packages. Once those packages are loaded, we need to define the range of the start date and end date that we want our date table to have. So we do that with these two variables. And you'll see that I'm using this function, the YMD. The YMD function, as well as another host of functions in the LubriDate package, allows you to parse dates in a very intuitive and easy way. Let's give you a simple example. You can pass in a string to the YMD function, and as long as it's meeting the pattern of year, month, date, the YMD function will be able to parse it as a date. So if I just pass it a string as 2017 01 01, it will parse that as January 1st of 2017. I can even pass it in a different format where I have the year with the month spelled out, and it will parse that out. You'll see that it's very friendly and it's not real strict in the string or even the integer that you pass into it. It is very forgiving, and it will parse what you pass into a date format. So that's a very useful function within the LubriDate package. So now that I have my start date and end date defined, I'm going to build a vector of dates using the base function called the sequence function. So by passing the parameter of my start date, my end date, and then how I want to increment, which is by days, I have built a date vector that spans from January 1st of 2017 to December 31st of 2020. And to see what that date vector looks like, I can do a head, dates, and then you'll see that it's starting from January 1st, and then it keeps it going on. The head function shows me the first 6 elements of the vector. And then the second thing that I want to define is my fiscal year and month. That's normal. That's an attribute that's very popular on date dimension tables. I did some work in the federal government, and the fiscal year end for the federal government was in September. It was September 30th. So for this date table, that's where we're going to use a fiscal year and month of September. So now I'm going to build the date table using the dplyr package. I told you earlier that the dplyr package is based off of what Hadley Wickham calls the grammar of data transformations. So there are 5 main verbs in the dplyr package that allows you to do sophisticated data transformations or even simple data transformations to your data frame. So one of the requirements of dplyr is that you can only work with a data frame. So we need to take our vector of dates and we need to convert it into a data frame using a data.frame function. So once we do that, that will convert the vector of dates that we created in line 7 to a data frame that has 1 column of dates. One of the nice things I like about RTVS over RStudio is that we go to our variable explorer, and sorry to see right now because I got this on the side. I can scroll that down. You see that we have this export to Microsoft Excel icon, which is, with a BI tool, if you didn't have that button, then your BI tool was incomplete. In RTVS, we have an option of exporting out to a CSV file, but not to a Microsoft Excel file. So I find this feature pretty handy. So getting back to creating our date table, we have this vector of dates, and we can view it by clicking on this view button. And you'll see that this vector of dates spans the start date and end date that we supply to the sequence function. What we want to do is we want to build attributes on top of or based on those dates that's in that vector of dates. So we can do that using one of the verbs in dplyr called the mutate. The mutate in dplyr is similar to something like the summarized columns in DAX, in that it's a verb that allows you to project onto your data set. So it allows you to build additional columns on your data set, or in the data science world, we would call those variables. So the first thing we want to do is build a date key. In Power BI, we really don't need that, but in a lot of BI environments, a date key is used to join the date dimension table to other tables in the model, but that's not really needed in Power BI. I just wanted to show you what syntax is needed in order to make that happen in Power BI. And then the second thing we're doing is we're getting a month name, and you see that using the format function in R, which is a native, which is a base function in R, you can see the string, the format string that we need in order to get a month name in R. With the next thing we're going to do is get the weekday name using the wday function that's in the lubriday package. If we provide an argument of the label equal to true, that will return the weekday name. Just scrolling through it, you'll see how intuitive the functions are that you can use in R that's either part of the base R or part of the lubriday package. You'll see the logic that we can use to get the fiscal year. A lot of these things in here are as easy to do in Power BI if you're using Power Query to create your date table or DAX to create your date table. But one thing that I find easier in R is calculating the ISO year and the ISO week. You see that in R, it's a simple function call. And if you were to do something similar in Power Query, it'd be more complicated if you had to do that with M. And DAX is doable. It's a function. You can use a week num function in DAX to do the same thing, to get the ISO week with an additional parameter, but ISO year is more involved to do in DAX than a simple function call that you see here in R. So so we listed the attributes that we're going to use or going to add to our date table. So the last thing we'll do is reorder the positioning of the columns by using a select. The select verb in dplyr does as it says, and that is it selects the columns from the data set that it's using. So to execute this, we'll just highlight the code and hit enter, control enter. And if we go to our variable explorer, you'll see that we've created a date table. So when I write scripts in R for Power BI, I like to do it within my the IDE of choice, whether it be RStudio or whether it be RTVS, our tools for Visual Studio. And then once I get the code working, I can copy and paste that code into Power BI. So I got code that's functioning. I can go over to Power BI, and I can go to my get data example. And to execute this that script in Power BI, I go to get data, then more. And once I go to more, I'll have the option of selecting other. Select other, and then I go to R script, and then click connect. Now I have the script editor that's available to me in Power BI. You'll see that the script editor in Power BI is nowhere near what it is if I was using our tools for Visual Studio or RStudio, as you'll see in later on in the presentation. So that's the reason why I choose to do my editing within our tools of Visual Studio or RStudio, and then once I get functional code, I copy and paste it in Power BI. So if I copy that here, click OK, as long as my script is returning a data frame, that data frame will be exposed to me after Power BI runs that script. So I click on the date table, and then now I have the same options that are available to me when I bring in data into Power BI in traditional ways. I can either directly load this to my data model in Power BI, or I can click Edit to do further transformations within Power BI before I load it into the environment. So that's using Power BI just to create a simple date table. Another situation that you may need to use R and within Power BI is if you were doing some sort of calculation that was math heavy, that would be hard to replicate in M within Power BI. So in this example, we have a file that has data that contains geographical coordinates. It has the lat long of the pickup and the drop-off points for from some New York City taxi cab data. So let's look at the data set real quick so you'll see what I'm talking about. So we go to the data set. You see that we have a list of 50 points of longitude and latitude pickup points, along with the longitude and latitude drop-off points. And what we want to do is we want to calculate the direct distance between both of those points. Now you can do this. I've seen it done in Power Query, but it's not performant, and also it's Power Query I don't think is the right tool to do that type of calculation in. But R lends itself nicely to that type of calculation. And we can make that calculation using the Haversine formula, which you see right here. So in this R script, we're using two packages, the dplyr and our readr package, to take data from a CSV file that we just saw and calculate the distance between those 2 points. And once that calculation is made, now that data set is made available to the Power BI model. So to run this script, just Control Enter. And if we go over to our Variable Explorer, and then we go to the trips data frame, you'll see that it did a calculation which by adding a column called trip distance, which calculated the direct distance between the two coordinates that we provided to the function as a parameter. We go back, let's close out of this. Let's close out of that. We go back to the function. You'll see how easy it is to define a function in R. You give it a function name, and then you start off the function with the word function, and you provide the function with the parameters that will be needed in the calculation. And then you enclose that function with brackets, bracelets, and in between those bracelets, you will have the code that you want to execute in that function. And at the very end, you tell R what you want to return. So now we know that we have functional code. What we need to do is highlight it, and then go to Power BI. We're going to go to get data. I can cancel all of that. And then go to More, Other, and then R script, Connect. And then we need to paste in our code. You'll note that I had this code up here commented out. When you write code in RStudio or RTVS, it has a working directory, and you can access files on your machine from the point of that working directory. But that working directory is not the same in the script editor for Power BI. So I need to explicitly tell R where to find that, what working directory to use, and I do that with the set WD function, which the WD stands for working directory. Click OK, and you'll see that the script that is available to us that's based off of an advanced calculation that was done in R. Okay, so Dan, we have to 1 o'clock.
Yes.
Okay.
Well, yeah, 1 o'clock probably your time. Sorry.
Okay.
Yep.
Okay. Okay. So what I'm going to do is I'm going to do another demonstration with using R as a data source, and then I'm going to jump into what I think you guys would like the most, and that's the visualization. I've seen a lot of people use R to create, to score data from a data science standpoint. They may have a model that they built in R, and they're using Power BI to score that data. I don't think that's the best way to do it. I think a better way of doing that will be to leverage, I'm sorry for moving around so much with the screen, will be to leverage SQL Server R services if you have SQL Server 2016 or later. With SQL Server R services, you're able to embed R scripts within SQL Server. Not only are you able to embed R scripts in there, if you have data sets that are humongous, well, SQL Server R services comes with a group of functions called the RevoScalar functions that allow you to handle big data in a more efficient way. It allows you to get over some limitations and that's available in traditional R, and one of the biggest ones being that in traditional R, you're limited to the amount of memory that you have in your machine. That's not the case with SQL Server R services. You're able to leverage not only the amount of memory that you have in your machine, but you're also able to leverage the disk space as well. So in this example, this is an example of a R store procedure in SQL Server, and you'll see that we have our R code up here, and one of the features, what just happened? One of the features, and I don't know what just happened. Let's close out some of these screens. I'll open this, expand it out. Yeah, one of the features and that we created was in the model that we're using, we created a feature that calculated the direct distance between the pickup point where the taxi cab picked up the passenger at and the drop-off point where they dropped them off at. So you'll see the R script being embedded in the store procedure. And then at the bottom, you'll see SQL Server defining the data types that is going to convert the data set that R has passed to it to. So you see, data types that you're very familiar with in SQL Server, for those of you that use SQL Server. So we can call that from Power BI, and we can do so by going to Get Data, SQL Server, and then we'll put in our server name. Let's go here, View. Get our server name. Then we go back to Power BI, put in our server name, and the name of the database in this case was NYC TaxiCab. That means TaxiDB. And then we want to make sure that the import is selected, and select the advanced options, and then we we want to execute that stored procedure. We do it by calling it, the name of the stored procedure that I just showed you was dbo.predict tip. So to execute it, just click OK. And what it's going to do is going to call that stored procedure in a database, score the data in the SQL Server database, and pass the output over to us. So now that you see that we have scored data, and I think this version is much better than trying to use R within Power BI to run a model. I think SQL Server with the resources that your server typically has is a better place to try to productionize your models versus doing it within Power BI. So another advantage of doing that is that you can also leverage some of your tools within Power BI to help you see how valid your model is. And this is something that some data scientists will probably appreciate. What I'm viewing right now is a what is called a ROC curve. ROC stands for Receiver Operating Characteristic Curve. Basically, what this curve is, it's a curve that's used to to see how good a logistic regression model is performing. And basically, the way it works is, it says that with the 45-degree angle line that you see that cuts the rectangle that we see in half, it says that that represents random. So if you have a binomial, or if you have a situation where you have a binomial model where there's only two possible outcomes, chances are that you will get 50% of them correct just by chance. So anything you get above and beyond that is considered, something that's better than just pure chance. So you'll see that in the model that we created, the model is not doing that much better than chance. And if we wanted to further slice and dice this model, we can add attributes, or we can add slices to the model that will filter and show us what how some other categories may be performing. So if we said, let's look at short length trips versus just by themselves and see if they predict better, you'll see that that's not too much difference as well. The same thing, we're able to look at intermediate length trips. Basically, what you can get from this slide right here, or this what I'm showing you right now, is that you're able to validate your models or look at your models not in the traditional ways, not only in the traditional ways using RStudio and creating plots there, but you're also able to look at your models and visualize the accuracy of your models and the performance of your models within Power BI. Note that we're using the R visual here, and we're using the library known as the ROC R library in R to create this visualization. So the last thing we're going to do is we're going to demonstrate a custom visualization within Power BI, and we're going to use the ggplot library to do so. So we're going to go to this library right here. In this PBIS file, we're using the ggplot library to analyze the player scores against other teams, and the other teams being the team that we're analyzing is the LA Lakers, and we're seeing how they how their players perform against other teams, which players perform the best. And one of the best visualizations to use, and one of the best visualizations to use if you're trying to analyze the dispersion of data, is the box and whisker plot. And that's what we're using here. What we're saying is we're showing for all games that the LA Lakers played, we're showing the players, the distribution of the player scores, and we're using the box and whisker plot in order to visualize that. Now you're probably looking at this chart right now saying that this is not nothing that to me is eye appealing. This is, you know, it just look like a basic Boston whisker plot. Yeah, I think you're correct in saying that. One of the things I want to know before I go into enhancements that you can make to this chart is that the filters, the outside filters that you have in your report propagates to your R visualization. So if I wanted to select the Indiana Pacers, I can select that filter, and you'll see that it takes a second to update. You'll see that that filter propagates over to my R visualization. Now with R, the visualizations are static, so there's no backwards filtering going on right now. I know that the Power BI team, they introduced some R plotly charts that, you know, that will in the future have that type of cross filtering, but where we're at today, that's not really an option. And the R plotly charts, I believe they're in preview right now, so I'll wait a while before you go live with those charts. But currently, what's in GA, there's no cross filtering with the R visualizations. So going back to this, you know, trying to make this chart, you know, more presentable and more production like ready. Some of the things that you can do with the chart is you can create more white space. The gray background that we're looking at may be, you know, not that appealing. And then there's some other things we can do. So if we go to B, let's take a second to refresh. You'll see that we've done some basic things to make this chart a little bit more presentable by taking out the white space. I mean, taking out the gray and putting white space there. But still, this chart is not really production ready. One of the things I want to point out before I go over to the last thing that we can do to make this more of a production ready chart is that if you want to create a R visualization, the first thing you need to do is you need to go over to your visualization and drag the R. You click on the R, and then that would create a box on your visualization panel that would be the area that you would create your R visualization in. Once you do that, if you click on that, you'll see that a box pop up, and it passes the data frame or data set that you created based off of what you put in your values. So in this case, we put in ID, opponent, player, and points. One thing to note is that you need to make sure whatever data set that you pass into the visualization, that each row is unique. If you don't do that, then R will collapse rows that are similar, which may return results that are unintended. So you need to make sure that you do something to your data set to make sure that the data set is unique when you pass it over to R. And I did that by using the ID field. So once you do that, you'll see that you have an IDE available to you that you can create your visualization in. As we said before, just like with the Power Query editor, it's not an editor that you really want to do any real type of R scripting in. Luckily, if you recall early on, we set an IDE that we can use for, as our default IDE in Power BI. And to get to that, we just click on this arrow going up at a 45-degree angle. If you click on that, it will open up your IDE of choice, which in this case is RStudio because we have 2017 on this machine, and it will take the data frame that you were building in Power BI, which is this data frame right here, and it will take that and persist it to disk, and it will save it in this location right here, and it will make it available to you as a data frame. And it also pass any code that you had in the IDE. Now I can do my data manipulation. I can do my code manipulation in a preferred IDE versus in that little editor that we saw before. So if we run this, now we have that data set that Power BI created in a data frame now. And you'll see that we're able to execute and test the code that was passed to R, and if we need to make any changes to that code, we can do so here. And this is a much better place to do it versus doing it within the editor that's in Power BI. Now, in Power BI, and R, remember R is based off of the grammar of graphics. So you see how easy it is to build plots in R, how you start with a base, and that base being the data set that you want to use, the aesthetics, and you can think of the aesthetics as the S coordinate, the Y coordinate, and then whatever type of colors you want to do in your grouping and things of that nature. And then after you define that, you see how you can easily build on top of it. You can go with that and then add on the type of plotting that you want to do. And then lastly, you can do things by, if you want to add titles to your chart, or titles to your S and Y coordinates, you can easily do that by building on what you did before. And the result of that we see right here is this visualization at the lower left. So note that when you want to get to the point where you want to edit the code that's in your charts, you can do so by clicking on that 45-degree angle. Lastly, the one that I think is production ready, and the thing that I think one of the things I think make R so great when it comes to data visualization, is how you can just do things that you can add dynamic elements to your chart. You can see here we have a situation where we have annotations on this chart, and this is right here would be hard to do with the custom tools in Power BI with the box and whisker plot that they have available in Power BI. You can see that it dynamically creates this annotation here. We can say, for all games considered, Brian scored the most points, and it was 61 against New York. We click on the Pacers. We'll see how the LA Lakers did against the Pacers, and you'll see that he was also the highest scoring person with 36 points. If we click on another team, you'll see that the annotation dynamically changes. And you'll see that when the Lakers played the Bulls that year, Gasol was had the highest score with 34 points. So this is just an example of how you can build annotations or dynamic features to your plot that would be super hard to do in Power BI using the native tools. Super hard to do, if not impossible. This will let you know what the code looks like. We got one more minute to go. If we were to okay, is it right? Okay, so you'll see that to add that with the annotations at the bottom, we had to create a separate data frame, and that data frame had the information that we needed in that annotation. And you see to add the annotation data frame was created with this section of code right here, and to add it to our plot, it was as simple as adding this right here to our plot. That right there allowed us to create a situation where we have a plot that is not only, I think, is production ready, but also it allows us as a data analyst or a BI professional to tell the story that we want to tell. It allows us to draw the focus that we want, the focus, to the area that we want it to be drawn to. So with that, are there any questions?
All right. Well, thank you very much, Ryan, for that overview of using R and Power BI. Those were some great examples. Thank you so much. Is it possibly by chance any of these samples you'll make available at all for people to take a look at?
Yes, all of them be added to the packet of information I'll give you tonight, so you can put on the website.
Oh, fantastic. Okay. The other quick question that I had was in example number 2 there, when you had the distance, do you know by chance how is that distance being calculated out? Is that in miles or kilometers, or do you know by chance?
It's miles. You
It's
see,
miles.
we go to
Okay.
the formula. You'll see that up here, radius in miles.
All right. Perfect.
This right here is doing the mile conversion.
Those were all the questions that we had. We do need to wrap it up. It is the top of the hour. I want to thank you so much, Ryan, for presenting today. Fantastic presentation, great examples and usage of using R stats in Power BI. Do you have any final parting words for the community?
Last parting word is, if you want to get started with R, I recommend a book by Hattie Wilkham called R for Data Science. The book is right here, and a free copy of it is online. If you go to r4datascience.had.co.nz, this is a great book. This is, I believe, the best way to get introduced to R. It's written by a guy who's, as I said earlier, is the most prolific R package developer, and he teaches you the best practices and the best ways to learn R. So I highly recommend this book.
Wow, very nice. See, look, that free gifts for everyone. All right. Thank you so much again, Ryan. Thanks for everyone that attended. Remember to fill out that survey, and we'll be doing our gift card giveaway. Thank you so much, everyone. Have a great day. Thanks again, Ryan.
Thank you.